Hello, my name's Rod Bishop, and in this short video I'm hoping to give you an insight into some of the soldering techniques that I use in creating these models. They're methods that I use. They may not suit everybody, but as you can see they have worked for me. Let's just have a quick look at some of the equipment that I shall be using in this video. First of all, I've got a 45 watt soldering iron here, which I use generally for the main construction of these models. And then for white metal work I use a smaller iron. This is a small 15 watt Antex. Irons like this Weller iron here have interchangeable tips. The tip that I normally use for general purpose soldering, i.e. for brass and so forth and nickel silver constructions, is rather large screwdriver style tip here. And then for sort of slightly more delicate work or electronic soldering, that type of thing, I've got a much smaller tip here. This is ideal for sort of if you're soldering onto track work, that type of thing, or some of the more delicate soldering on brass kit construction. Basically, with any iron that you purchase, it's crucial to make sure that you can get replacement tips for it. Indeed, with these Antex, this is the small tip they tend to come with, but you can get different size tips for them. And as far as solders go, for the general construction of the models, I use this 145 solder, so called as it melts at 145 degrees. The flux that I use with that solder is this paste flux. This happens to be a power flow flux, but generally speaking most of the paste fluxes will give you the same result. We'll look at those in a little bit more detail in a moment. I do sometimes use a slightly higher temperature solder, something I'll come to a little bit later on as we go through the video. That particular one melts at around about 190 degrees. For white metal work we'll be using some of this phosphoric acid flux. This one's marketed by Duncan Models, and with that we'll use some 70 degree solder. A quick word of warning about the solders. Most of these solders do actually contain lead, and also with the fluxes they all tend to be some form of acid base, so hand washing before eating is vitally important, and also sort of hand washing throughout your modelling time, because if you don't want to get this on your fingers and get too much contamination from it. Quick word about the maintenance of soldering irons. Don't ever be tempted to file the tips of your soldering irons, because on these modern irons they are basically a copper coated tip. They are copper underneath, but they're not copper on the surface, and if you're tempted to file them you'll actually destroy the tip. The best way is to keep them cleaned with a damp sponge, and I emphasise a damp sponge. Don't make it too wet, it just needs to be kept sort of fairly damp. If the bit does become a little bit too tarnished up and cruddy, you can always use this brass stuff that I've got here. A little bit more abrasive, but it won't actually damage the tip, it's just literally brass turnings. If that doesn't do the job, you can buy this tip cleaner. Right, with the tip cleaner, let's have a look at this small iron here. It's a little 15 watt Antex iron. If the bits become sort of very tarnished and sort of very cruddy on the ends, you can just literally put them in the tip cleaner and you'll end up with a nice bright clean tip on the end of your iron. And then just rub it on the brass there or into your damp sponge and you'll have a nice clean tip ready to solder with. Okay, this stuff's quite expensive, but I've had this one for a number of years, and it does last. So it's not a vast capital outlay, because the length of time it does tend to last. One of the other items that I get asked about a lot is this unit here, which is a resistance soldering unit known as an RSU. We'll look at that in a little bit more detail later on. Right, while I'm talking about irons, the one you see here is a Weller solder station. It's quite an old Weller solder station, but they are still around on that sort of well-known auction site. It's a very, very good quality iron. I've had that one for a number of years. You don't, however, need to spend a fortune on irons. You can use something like this Antex iron here. This is approximately 40 watts. I think they sell for around about sort of £30, something like that. They are quite sufficient for sort of a lot of the work you'll do in modelling. The one disadvantage they do tend to have, though, this particular one has a PVC lead, and they are quite easily damaged if you're not very careful. So if you're going to buy one, you can often buy them with a silicone rubber lead, which is well worth paying the extra for, because the one advantage with a silicone rubber lead, it will not burn, where of course PVC one will. This particular iron's running on 24 volts, where if you have an iron like this, it's running at mains potential, so the last thing you want to do is burn through your mains lead. Right, let's look at some soldering techniques. Brass to start with. Now, with any form of soldering that you're going to do, the most crucial thing is cleanliness. Now, there's various methods you can use to clean brass. Here I've got some Scotch-Brite. This is commercially available Scotch-Brite, normally available at most decent tool shops, decorator centres and outlets such as that. The other thing, of course, is the old fiberglass stick or the fiberglass pencil, which I'm sure a lot of you are familiar with. If the brass is really tarnished, the other thing we can always go for is some wet and dry. This is sort of 600 wet and dry or 400 wet and dry, something like that. But with the brass I've got here, the Scotch-Brite should be sufficient. So the first thing we need to do is clean up our brass like so. Get rid of all the tarnish on it. Even with a new kit, they do need a bit of a going over. This is just some bits of scrap brass I've got here just to give you an example. Now with the flux I'm going to use, again, this is the Power Flow flux. It's a paste flux. Some people I do know prefer to use a liquid flux, but I've been using paste flux for a lot of years, and all the models you see here were built with a paste flux. You don't need to have vast quantities of flux, just literally what's on the brush there. And what I'm now going to do, we'll form a little joint with those two, and you'll see how easy the process of soldering is. Nice clean tip on the iron. We'll pick up some 145 solder on the tip of the iron like so. Get these two together, and then just put my iron in there like so, and then just slowly move the iron along, letting the heat of the iron go into the joint like so. There we are, simple as that. If we want to tidy that joint up, we can just literally run the iron down it again and just clean the joint up. Not moving too quickly or too slowly, just letting the heat of the iron go into the joint and do its job. There we are, we have a joint now made there, perfectly solid. Solder's gone through both sides, so we know we've got a nice sound joint. That's literally all there is to soldering brass. Now, that having been said, if we were soldering a long seam, such as we've got on this coach sol bar here, I would have started at the middle of the joint and sort of worked either way out, allowing the brass to expand with the heat, and putting a little couple of tacks in place just to hold the sol bar temporarily in position while I soldered the full joint as I've got here and here. I don't know if we can see that with the camera. Right, moving along then. The other material that's used a great deal in modelling is nickel silver. Just as easy to solder as brass. I'll see if I can find a couple of scrap bits of nickel silver. A little bit there. Again, we'll clean that up. And we'll just solder that up with a couple of little bits of nickel silver. Let's find the other piece. We solder a couple of parts together. That round that way, I think. Again, make sure that's nice and clean. Remove any possible traces of tarnish on the material you're going to solder. Just add a little bit of flux on there. A little bit of flux on there. Again, we don't need vast quantities. Clean up the tip of the iron, pick up a little bit of solder, put the two together, and just let the iron move along there nice and slowly. Let the solder flow in. Job done. Just let that cool off slightly. I do have asbestos fingers, I should point out. There we are, and we've got a nice neat joint there. A nice solid joint. And that's the technique that's been applied again to the models you see here. One other item I often get asked about quite a lot is soldering white metal onto brass or white metal onto nickel silver. Not a complicated process at all. Again, we need to clean our brass up, either with Scotch-Brite or with something like a fiberglass stick I've got here. And again, just clean up that piece of white metal. This is quite a delicate piece of white metal I'm going to put on here. And this time I'm going to use an acid flux. It's a white metal flux. And I have here a small stick of white metal solder. And all I'm going to be using for this is literally a little 15 watt iron. So I will just literally run some of the white metal solder flux on there. Again, a nice clean iron. I'll pick up some white metal solder on the tip of my iron. Bring the two together, and bear in mind it's a little 15 watt iron. Just let that flash off. And there we are, we have white metal soldered to brass. Simple as that. You don't need a great deal of heat with white metal. Even soldering it onto brass, it will solder very, very easily. Okay, the next thing we'll look at now is something I get asked about a lot at various exhibitions and shows, is resistance soldering. Now that is achieved with this unit I've got here. This is a semi-homemade unit. They are commercially available. And the system I've got here works pretty much like any of the others work. We have a ground plate here, which is actually in my case is made of steel. I'll come to that in a moment, why it's made of steel. And we have a probe. The probe consists of a carbon tip, which is basically where we get our resistance from. This particular unit, the principle they work on, they pass a low voltage but very high current through the tip. And the tip being made of carbon gives us our resistance, and therefore with the resistance we get heat. And this is a very useful method of soldering, particularly in detail. So if I just show you the end of this brake van here, you'll see on the end of the brake van here we've got these lamp irons. They were fitted with the RSU. Very delicate little things to fit, much easier to do with a resistance soldering unit than they are with a soldering iron. And I'll give you a quick little demonstration of how we would attach something like that to a model. So using some scrap brass that I've got here, without knocking the lamp fly. The reason this is steel is I can clamp my brass to it with magnets. So if we just clean up this piece of brass here, and I make up a small bracket out of some scrap brass that I've got lying around here, so I'll just cut this and make a small bracket. I'll give you an insight into the way that resistance soldering works. A little bit of a crude bracket, but should sort of give you the idea. We'll clean that up as well. And what I'm going to do to this now, I'm just going to tin this with some solder, some ordinary, in this case it's going to be 145 solder. So we'll put a little bit of flux on there to start with. Don't need a great deal of solder, just a small smear literally on here. Like so. Sort that away there. We'll put a little bit of flux where we want to put our bracket. I'll pop the bracket on there. And one thing perhaps I didn't explain, and I should have done, is on the floor here I have a foot pedal. This is basically what switches the RSU on and off. So I just simply put my probe onto the bracket there. I can hold it in place with the probe because at the moment it's cold. As soon as I put my foot on the pedal, current passes through the carbon, heat's generated, the solder's melted, take my foot off the pedal, I can keep holding it because the probe is now cold and the joint's cooled down, and our bracket is soldered on. Simple as that, with little or no cleaning up. So that would be a classic example of fitting a lamp iron. Something a little bit more sophisticated. This is a connecting rod from a locomotive, a laminated one. If we wanted to join those two halves together with an RSU, something you can do with a soldering iron, but it's much easier with an RSU unit, a resistant soldering unit. I'll clean up the two halves of the connecting rod. And what I'm going to do, I'm going to tin one half, again using the power flow flux. So we'll just run some solder onto that, a little bit of flux. Some 145 solder. Tin the other end. Tinned on one side. Put that over there for the moment. We'll put some flux onto this piece here. Onto the other half. And well, that's all now ready to solder together. Okay, having got one half tinned and one half with the flux on, we need to align them on the base plate here, the business end of a dart in this case, which seems to work quite well. I've got my RSU on a relatively low setting, so I'm just going to hold up this end here, just put my RSU on it, foot on the pedal, foot off the pedal, just grab a needle file just to hold that, and then just work my way along with the RSU like so. I'm keeping my foot on the pedal but making sure the probe remains in contact with the connecting rod, and just gently moving it along, letting the heat flow through. Foot off the pedal, keep holding, just let the solder flash off, in other words cool down. Just give that end another little tap just to make sure we're soldered. Foot back on the pedal again, and foot off the pedal. Right, we'll just let that cool off. Take our pin out, and there we have a coupling rod joined together. Just a quick rub up with a piece of Scotch-Brite will take off any marks left by the tip of the RSU. Now we have two pieces of nickel silver, in this case a connecting rod, perfectly joined together, with virtually no cleaning up required, just a slight touch of a file down the edges just to sort of clean them up, but there we are. Right, one other use for the RSU, which I use a great deal, is sort of fitting boiler bands like we've got on the loco here. And there's a small section of boiler here, it's actually a smoke box, but it'll work just as well with this. Applying the boiler band to a boiler. First thing again, cleanliness once more, needs to be cleaned up, and of course I'm using very thin brass here, so we can only sort of rub in one direction, otherwise I'm going to distort the boiler band. So I shall just clean up the boiler band like so. This is a piece of brass around about 3/1000 inch thick, so it is very delicate. So we'll just apply some flux to the back of that boiler band. Like so. Now we want some solder. We'll just flow some solder along the back of the boiler band like so. I'm going to move the boiler band and keep the iron still on this occasion. Right, there we are, just just a light tinning on the back of the boiler band. Now in this case, because it's only a small piece of brass section I'm using, I'm just going to clamp this in place with one of the magnets. Previously cleaned up the brass of the boiler, so that'll suffice for this exercise. A little bit of flux where I want to start the boiler band. We're just going to tack this end on. There we are, we've got one end tacked on, nice and solid. I'm going to pull the boiler band around the boiler. After I've applied some flux to the area I want the boiler band to be soldered in. Just run some flux around like so. Don't need a lot, just enough to cover the area we're going to solder our boiler band. So we'll pull the boiler band around. And on this occasion I'm going to put the magnets back in just to hold it while I tack this end. Right, that's now held in place. I'm just going to snip off the excess there for the moment. Now the method I use when I'm doing this, I've got the RSU on a low setting. I put my probe on the boiler band, my foot on the pedal, and we just keep on round as we go round. Just moving it over gently over the boiler band, but not letting it come off the boiler band. Again, foot off the pedal. I'm just reposition slightly. Back on the boiler band. Foot back on the pedal, and just round we go like so. Right. The reason I do it in this method, if you do this, foot on, foot off, foot on, foot off, and keep moving the probe, you'll end up with a spot welded effect on the boiler band. Any discrepancies can be hidden underneath the boiler. Okay, so if we look at that, I'll just clean that up with a little piece of Scotch-Brite. So that's the effect we'll get with our boiler band. Perfectly joined to the boiler, no excess solder, and a perfectly solidly fitted boiler band. Right, one other item we can do with the RSU unit, which might surprise some people, is that we can actually solder white metal with the RSU. Now we all know that white metal melts at a very, very low temperature, but what I'm going to do, I'm going to actually solder a chimney onto this sample boiler we've got here. So the first thing I'm going to do, put some white metal flux on there. I'm going to tin the area with some white metal solder. Let's put a little bit of tinning of white metal solder where we want to put our chimney, like so. And I shall take the white metal chimney, a little bit of flux on that, like so. Position our chimney in its correct position. I've still got my RSU on a very, very low temperature setting. Right, so I've just got something temperature resistant just to hold that chimney in place while I apply some heat. Now, we don't put the RSU probe on the white metal, we put it on the brass. Put my foot on the pedal and we just let the heat of the probe go through the brass and flash off the white metal solder. Foot off before we take the probe off, and once again put the probe back on, just let the heat go through the brass into the white metal. Foot off, probe off. Don't be tempted to take the probe off before you take the probe off the brass. If you keep your foot on the pedal and take the probe off, you can actually draw an arc and damage the white metal or indeed the brass, particularly if you're dealing with delicate brass frets. Okay, so there we now have our chimney securely fixed on and no damage to the white metal. Now that method can also be applied when fitting buffer buffer shanks or buffer stocks to a brass kit, that's how these were indeed fitted. And in this case the item would have been clamped down and the probe put onto the brass, and the heat would have transferred through the brass into the white metal solder, melted the white metal solder, allowing the buffer casing to go into the brass buffer beam. Right, to go back to the RSU units, I keep referring to the fact I've got it on a low setting. For most items I find I have the RSU on a low setting. Most of the commercially available ones like this all have around about 6 settings for different temperature levels. This is its lowest setting. I can go up to a high setting up here for doing some really heavy chunks of cast brass or whatever, like some of the lost wax and nickel silver castings that are available for some of the kits. But generally speaking, I find it works just as well on sort of the low and medium settings I've got on this one. The commercially available ones use a slightly different method. It's a question of how you plug the probes into them, but that will obviously be dealt with within the manufacturer's instructions. And as far as they go with using them, it's a question, a lot of experimentation to find the best results for the particular piece of equipment you've got. And I would always suggest that you try on pieces of scrap brass to start with. Okay, that just about sort of concludes the RSU uses. It's great for things like overlays, just to sort of add that in, the sort of overlay we've got on the side of this sol bar here. You don't get any excess solder, just tin the back of the overlay, put it in place, and then working normally from the middle, just work along with your probe. Okay, one other aspect of soldering that I'm often asked about is electrical soldering to electrical joints, wires to rails, wires to switches, etc, etc. Slightly different principle here. This time we're not using the 145 solder, we're using cored electrical solder. This contains the flux, it's actually got the cores running through it, and we're going to use that to make a couple of electrical connections. And a classic example here is a little piece of tag strip. So if we wanted to put a wire onto that tag strip, well, I just chop off a piece of wire. I'll give you an example of the sort of thing we would do there. So we strip out a wire like so, and we just twist the ends of the strands together and we tin it. I call this the chopstick method. Okay, so I would tin it like so. You can use chopsticks, you can tin your wires like this. If you can't, you can put a piece of blue tack down, put the wire in it like so, and tin it thus. Okay, so we've got the end of our wire tinned. Let's get that blue tack out of the way for the moment. I'll just trim that down a little bit because we've got a little bit too much there. What we're going to do now is we're going to form a little hook on the end like so. We'll put that into the tag like so. We'll just crimp that. And then what I'm now going to do is I'm going to put my iron on the joint, which will heat the joint, and just add some solder to it. There we are. Take the iron off. Put the iron onto the joint first and bring the solder in. No extra flux has been used because we've got enough flux in our solder. I'll just make another one of those just so you can see how they go. Just cut off another piece of wire. Just twist the strands together. And I'll just tin the ends of those, and again we've got flux in our solder, so we're not adding any extra flux into it. Just forming an end on that, just trimming it off to make it a little bit neater. And this could quite happily be a switch connection or a piece of tag strip as we've got here, or even a connection to a motor in a loco. In which case you'll probably be using a much finer cable with a smaller iron. Again, we'll just put the tip of the iron on the joint, let the joint come up to temperature, add the flux in, take the iron off, and we've got a perfectly sound soldered joint. Okay, that's onto tag strip, switch connections, things of that ilk. Right, one of the other queries I often get is soldering wires to track. Obviously you would have your track normally in that fashion, but for ease of demonstration, we're going to have our track on its side so we can see it with the camera and so forth. The crucial thing is this is quite an old piece of track, so it needs to be cleaned up very, very thoroughly. Got it on its side there, so we've got that nice and clean now, and we're just going to tin that with a little bit of solder, put a little blob of solder on there, like so. So we'll put our iron onto the joint first, let the joint come up to temperature, and then just add a little bit of solder in there. And we'll get a nice little blob like so. The next operation, a little piece of wire, just to give you the idea. I'll just tin the end of this again. I'll just neaten that up a little bit, it's a little bit too long. And what I'm now going to do is sweat the two together. Hope we can see that we're right with the camera. And we'll just literally sweat the two together, like so. There we are. Okay, that should now be a very solid joint on there. So that's as simple as that, to solder a wire onto the side of the track. No extra flux has been used, just literally the flux that is in the solder itself. Right, we've looked at various methods of soldering. How about desoldering? I'm often asked about how to remove solder. Well, one of the methods I use is this desolder braid. And it has been said to me in the past, yeah, I've tried that, but it doesn't seem to work. Well, the trick is, just dip it in some flux. We'll get quite a lot of smoke when I do this, but if we just put this onto this blob of solder I've got here, you'll see immediately the solder is drawn straight into the braid. And we can just run that over there like so, and just take off any excess solder off the brass, which is taking it down like so. And if I then go over that with my fiberglass stick, just rub it like so, our solder now has pretty much disappeared. Okay, so that's basic solder removal. Well, that concludes this short video on soldering. I hope you found it informative. Thank you for watching, and perhaps I'll catch up with you at a show sometime. Bye for now.